Let's know something about electron probe microanalyzer, or known as EPMA. This is a machine setup of an EPMA. An electroprobe microanalyzer or electron microprobe analyzer is an analytical tool used to non-destructively determine the chemical composition of small volumes of a solid material. It works similar to a scanning electron microscope. The sample is bombarded with an electron beam emitting X-rays at a wavelength characteristic to the elements being to be analyzed. This enables the abundance of elements present within a small sample volume. Typically 10 to 30 cubic micrometers or less need to be determined. Certain models of EPMAs can accurately measure the elements having a concentration of approximately 10 ppm, that is parts per million. Principle: electrons emitted from the electron source are accelerated at a certain accelerating voltage and collimated through an electron lens. When the electron beam hits the specimen, X-ray is generated from the specimen. By dispersing this X-ray using a dispersive element, the compositions of the specimen is examined. This type of a spectrometer is called as a wavelength dispersive X-ray spectrometer, or WDS. It works on the same as XRD, that is on Bragg's equation. When an accelerated electron hits a specimen, in addition to X-ray, particles and electromagnetic waves carry various kinds of informations which are emitted. With EPMA, signals such as characteristic X-rays, secondary electrons and backscattered electrons, etc. are detected by appropriate detectors, and the information is utilized to find the area of interest of the specimen and for further information to analyze. Working: EPMA consists of 4 major components from top to bottom, that is electron gun, condensing lenses, optical microscope, spectrometers or the detectors, and the vacuum pump. An electron source or a gun is a tungsten filament cathode referred as a gun. A series of electromagnetic lenses located in the column of the instrument used to condense and focus the electron beam emitting from the source. This comprises the electron optics and operates in an analogous way to light. A sample chamber with a movable sample stages X, Y, Z, that is under a vacuum to prevent gases and vapor molecules from interfering with the electron beam on its way to the sample. Hence, a light microscope allows for a direct optical observation of the sample. A varieties of detectors are arranged around the sample chamber that are used to collect X-ray and electrons emitted from the sample. The next very important in a electron probe microanalyzer is sample preparation, that is fixation, fixing with the chemical products. Next, rinsing and straining, treating with heavy metal compounds. Dehydration or dehydration is dehydrating with organic solvent like acetone or ethanol. embedding in resin, mean materials are gradually infiltrated with the still unpolymerized resin. Trimming means rinsing the block and making ultra thin sections. Collection of sections onto a grid. These are the stages in preparation of a sample. Advantages. An electroprobe is a primary tool for chemical analysis of solid materials at a small spatial scale. Spot chemical analysis can be obtained in a suite, which allows the user to detect even small compositional variations within the textural context or within the chemically zoned material. Limitation. EPMA needs an expensive vacuum environment for proper preparation. It's highly dependent on probes. Errors do occur due to interaction. Electron probe unable to detect lightest elements of hydrogen, helium and lithium. Probe analysis also cannot distinguish between different valency states of ferrous. Application. It is having wide good application in geochemistry, mineralogy, geochronology, physical metallurgy, nuclear metallurgy, material science including glass, ceramics, superconductors, cements, microelectronics and biochemistry. EPMA provides much better results than standard SEM system. Because of the internal properties of WDS, the general sensitivity, analysis of light elements and risk of erroneous interpretation of qualitative spectra are widely superior than EPMA. With EPMA, spectral resolution and detectors dead time are much better than EDS. The excitation beam regulation system and sophisticated sample stage capabilities guarantee that this technique provides outstanding stability and measurement repeatability. This ends the electron probe microanalyzer. These are my references for all the sessions. And these are the references for preparation of my slides and videos. Thank you.